So what we're going to look at today are statistics and how they can be used badly or misapplied, or bad statistical practice, and why we have to be careful with statistics. So the goal is to have a healthy skepticism of data and statistics, while also acknowledging the importance of data and quantitative information and statistics. Because it is important to be able to have a numbering of things that we see and think about and look at and study in the world. It is important to be able to represent those things in numbers that can tell us a little bit more about the reality of a situation, because it's often common for us to feel a certain type of way about things, or to think that what we experience is happening all the time to everyone, or more commonly than it actually is. And so numbers matter. There are things that, if you look up the actual number of them in terms of raw numbers, and raw numbers means it's not a statistical percentage, but the actual number of like occurrences in a given area. If you look up the raw numbers of something, you can see it can give you perspective or context. So we often think, okay, well, I feel this in my life. Is there any data that shows what I'm feeling to be correct, or is it just a feeling? So it is important to be able to gather data and aggregate it and be able to make meaningful statements with data. On the other hand, given that importance and given that level of authority that's been given to numbers, people take that and they do shoddy statistical practice, and people often see those things and think, okay, well, I'm seeing quantitative data. I can't question numbers. Therefore, I have to accept whatever is put before me. Or they feel like it's not quite right, but they don't have the framework or the questions or the critical thinking skills to articulate what is wrong with what they're seeing. And you have to be careful, because all statistics come with an agenda. There's bias in different things, and you can get to truth even amidst bias, but we still have to recognize that it's there. And one helpful question that you can ask, not necessarily out loud, but in your own mind, whenever you are presented with numbers, data, and statistics that are trying to communicate something to you in order for you to think a certain way, one simple question you can ask in your mind is, what is the methodology? Meaning, how did they get to those numbers? How did they arrive at their conclusions? Are they upfront about how they got to their conclusions? Methodology is the step between a question about something and the answer that they conclude. good methodology and honest practitioners and good practitioners, there's a difference between people can be honest but also be mistaken. But it is good statistical practice to make sure, or practice in science, in economics, in history, in many fields of study, to articulate outright and clearly what your methodology was, how you counted things, how you got your information, the limits and weaknesses inherent in what you're trying to study and what it is you're trying to say and conclude, how you bring about a way to count up your data and aggregate it and make sense of it, how questions maybe have been asked in surveys, and how that might have knowingly or unknowingly led someone to a certain response, whether the data is new or old or current or not current, whether the data is shown over time. These are all questions that should be answered when someone gives you statistics. They should be answered in the methodology. They explain, well, this is how we gather the information. This is how we decided to count it. Here is some of our limits and weak points in our study. Here's the reasons why we think this is the best way to do it. Here are our justifications for our reasoning. And here are our conclusions, or what our research suggests. But the best the best research and honest statistics leave themselves open to correction. Bad statistical practice usually hides its methodology or is not upfront about the methodology, because what a methodology allows people to do is to see the mechanism of how you arrived at your answers. It allows a vulnerability for others to critique what it is you're trying to say, knowing that you could be wrong. And this is something I think that is missing a great deal in our modern time, is intellectual humility, in the sense to think through things, but open to the possibility of correction, knowing that we are mistaken. Not all the time, but that we can be mistaken. This is one of these things that people say in arguments and things like that, that you always think you're right. You always think you're right. But everybody always thinks they're right. That's what thinking is that we don't, what's the alternative? If we automatically always thought we were wrong, thinking would not be possible. So we always think we're right. However, intellectual humility, and I would say intellectual maturity, is to go to the next step, which is, while we always think we're right, we should not think we are always right. Which means we know that while we generally think we're right, we know that there is the possibility where we can be wrong, and we could be wrong in an area that we have missed. We know that we make mistakes. We know that we miss things, and we know that we have passions and non-neutrality that causes us to more easily see things, some things, and not others. We recognize the possibility of blind spots. just like driving in a car. So methodology, just simply asking, whenever you're presented with something on the news, presented with something school, my class, other people's classes, presented with something in your later professional lives, political information, whatever the case may be, ask, what is their methodology? How did they arrive at their conclusions? And what do they want me to do because they got to their conclusions? What is it they want me to think? How is it they want me to think differently than I now think, or reinforce what I'm thinking because of the conclusions that they're drawing? And let me give you guys some examples of history and economics. There are different schools of thought that look at the issue of slavery and ask the question, which is empirical, but takes some work because you have to go back in and study history and economics to get an answer. But they study, was slavery an economically productive system? So that question gets asked, and there are schools of thought that say yes and schools of thought that say no. One school of thought goes back and it measures the economic output created by slavery in the United States. And it also looks at the economy, the things like the cotton economy and how that was intertwined with other areas of trade and the economy. And it determines that slavery was economically productive in the sense that it produced and was interconnected with other aspects of the US economy during that time. And therefore, their conclusion is that the wealth of the United States was primarily founded on the wealth building of slavery, that even in the free states, and even in places where slavery had been gotten rid of, because it intertwined with that economy of the slave states, that all the wealth of the United States depended on slavery. Now, what is their methodology? Well, partly their methodology is correct, that it looks at the economic output and the economic production in areas that were using slave labor. Where it was incorrect, the methodology, is that it double counted things and transactions, which in economics, you don't do that. That's not how you arrive at what's called GDP, gross domestic product. In addition, their question, was slavery productive, can be corrected, because what are we trying to measure? How productive was slavery? Productive, an economic question, is relative to what? If we're saying slave labor versus no labor, then of course slavery is productive because it produces more than nothing. But if you measure slave labor versus free labor, which it is possible to do, and all the expenses and the enforcement costs and all the things that had to go into to maintain the system of slavery versus free labor was much cheaper and much more productive. In addition, if you look at output in areas that have traditionally been produced by slave labor, like the cotton economy in the 1850s was producing quite a bit, But after slavery was legally ended, the cotton economy grew even larger. So even under free labor, it was larger than under slave labor. So there's these different schools of thought looking into an issue, studying economics and history, and coming to vastly different conclusions about these things. So let's look at some examples of statistics, how to do bad statistics or bad statistical practice, just in general. That the slavery thing was just an example of how different practitioners in a field, both working hard and doing research, can come to different conclusions based on different methodologies, different presuppositions, different questions that they start with. And so statistics is a very useful tool because statistics allow for the fact that there's this mathematical principle that when you want to get statistical information that is accurate 95% or even 99% of the time, it doesn't require that you ask, let's say about the United States, it doesn't require that you go to every single person in the United States, give them a survey, have them respond to it, and then count up the data from there. You can do some practices of a much smaller number and get accurate information about the United States on average by a random sample size of a much smaller proportion of a representative sample. A representative sample means it's a grouping of individuals who represent the overall whole. And if you gather from them randomly and you ask, the questions and things in a way that makes sense, it's careful to get good answers, then you can generalize and say this is probably true for the United States overall with a 95% probability. So statistics are very helpful. They do allow for a very useful shortcut, but it can also be used and abused very for bad purposes. And the scary thing is a lot of times, or maybe I should say the disturbing thing is a lot of times people who are practicing bad statistics don't know that they're doing it, and they don't necessarily think they're doing anything dishonest. They're not trying to deceive. They're not trying, at least directly, to mislead. Now, they may be self-deceived, as we often are. Now, it's like, well, how can you deceive yourself? If it's you doing it and you're tricking yourself, how do you know that that's going? But we're often willing accomplices, that we want to believe certain things and we're willing to tell ourselves certain things in order to hear what we want to hear and believe them. I think we do that more often than we'd like to admit, and other people do as well. It's a human practice that it's not that we lie to others, but often we lie to ourselves. And so the interesting thing is here, but as I said, the disturbing thing is if you gave people who did bad statistical practices a lie detector test and you said, were you trying to trick people? Were you trying to mislead people? And they said no, they probably passed the lie detector test. So it's not always outright lies. Sometimes it is, but often it's just people not recognizing that they are skipping steps and choosing information that they already are assuming, rather than letting their method and their data and their information show that, and being open to correction. So one way you could do this is gather from a non-representative sample, right? Just say you took a survey, and you could ask how you ask a question on a survey is hugely important, because it could lead people to answer a certain type of way. You could also cherry pick the results, that if you look at, all right, for some reason, let me take these answers versus those answers. It can also get published. Now, to get published in a peer-reviewed academic journal often takes a little bit more rigor than just putting something out there on a blog, obviously. However, there have been cases where people have turned in, pure nonsense on purpose to certain academic publications, but they made it kind of smart sounding, and they got published. They got approved by several peer-reviewed journals in certain areas. And you could look that up as well. And then there's also dishonest ways of getting published. For example, there are sites where you could look up and pay for, like, I don't know, this is imaginary, but let's say nutrition science or something like that. That sounds official, right? You could publish with that name. You pay a fee, and they create your paper for you, and then you can cite it as a source, which is unethical and very dangerous to do that. However, that is like the other end of the spectrum, outside of academics, where it is possible to get on the internet and find things like that. And then this is where good research usually is a lot more modest with what their conclusions are. They say, okay, well, here's kind of the limits of our research. Here's what we did over and over and over again. Here's where we're not sure about things. But here's what we tried to mitigate that and get to a better result and better answers and all that stuff. But here's what our research suggests. It should suggest that in some people, here's just a fake example, but in some people, in limited circumstances, cranberries may be good for preventing certain types of cancer or something like that. That might be a modest claim of some true scientific research that was seeing some certain results, but it doesn't want to get too bold in its conclusions. However, you get these press releases that will take something, say, cranberries cure cancer. Somebody writes a blog on it, somebody republishes it, and then somebody ends up on Dr. Oz, and they say, yeah, cranberries, they cure cancer. And that's not what the conclusion of the research was. That's not what the research was saying. However, it's very common to say, okay, well, all these papers, 90% plus of these papers in this scientific area agree with me on this issue. When really a lot of those papers had nothing to do with that particular issue and may have only mentioned it in passing without any commitment one way or the other. So let me show you some things where they're graphs, they're real, and I don't think anybody behind them was doing anything, had malicious intent. I don't know, but I don't think that's the case. But I want to train you to ask questions of the data that you're presented. This isn't actually original to me. There were several of these things that I got from a PowerPoint of a guy who was doing a training for teachers. and a few years ago, and I borrowed some of these graphs to show just how statistics can and data and stuff can be kind of misrepresented or presented in kind of a funny way. So 2016, there was this press release from the U.S. Forest Service that the number of dead trees in California's drought-stricken forests has risen dramatically to 102 million. Okay. What other information would you need to know to have perspective or context for this? Notice, I would want to know how many trees there are total. I would want to know what counts as a tree, because I know that's a very basic question. It seems to be highlighting these, areas of California's forests and stuff, but I get that. My point is, are we counting juniper trees, Joshua trees, cacti, those type of things, or just certain types of trees? I would want to know, okay, it says that it's risen, okay, and notice the language is value-laden language. Drought-stricken. And risen is not value-laden, that's empirical, but risen dramatically implies something else. Now, a number here, okay, this is empirical, but I'd want to know, what about 2015? What about over 10 years? What about over 50 years? Has it ever been this high before? How many trees are there total? Because if there are billions of trees, then remember, just for some perspective, that a billion is 1,000 million. And so if there are billions of trees in California's forests, 102 million is not that much of a number. It may have risen from what it was before, but that increase is not what we might be led to expect. Right? So there are probably, if we sat and thought about it, 20 questions that we could raise that would give us fuller information about this type of thing. Another common mistake is mistaking correlation with causation. Correlation means that two things are happening simultaneously, happening together, but we're not really sure what the connection is between them, or if there is a real connection between them. The world is pretty complicated, and each thing that happens in the world is connected in some way. But that being said, that's very different from saying that one thing causes another. So correlation is that these things are happening together, occurring simultaneously together, but the connection between them is not obvious and may not mean anything. Causation is that one thing causes another, and that without that cause, that thing would not happen. So here's an example. This is true. Per capita cheese consumption correlates with the number of people who died by becoming tangled in their bed sheets. Okay, so these things happen together. Now, it's okay to say, okay, that's weird. That's interesting. I wonder if there is any type of further connection between these things. However, it would be a mistake to say or assume that one thing causes the other. For example, it would be a mistake to assume that eating cheese causes in some indirect way people to become tangled in their bed sheets and die by that means. Here's another one. That imports of fresh lemons from Mexico seems to correlate with less highway fatality deaths in the United States. So they happen together, but it would be a mistake to say that, all right, let's import more lemons so that we may have less fatalities on US highways. there's a correlation between the number of pirates in the world versus average global temperature. Here's another one. It's the average housing price, 1998, 1999. Now, there's some questions as to this graph. Why doesn't the graph start at 0? In terms of, why does it start at 79,000? Because if you zoom in, this difference may look a lot more dramatic. But if you look out from starting from 0 to 82,000, then there's not as much difference between these two things as it would appear. It looks like this is about half of that. And then why just these 2 years? You have to be careful where a graph starts or where statistics start and measuring certain years. For example, this is fairly common. You want to, it may be the earliest year data is available for a certain measure. However, sometimes people just pick a certain year. Let me give you some examples. Australia, a few years back, I don't remember the exact year, but Australia a few years back implemented some much stricter gun control. And after, that is antecedent, after implementing that gun control, the gun crime went down, decreased. Okay, now we could say that that was a consequence of the gun control. And it may in part be, but what was happening before the year that is commonly presented, okay, here's where the gun control was implemented. Well, if you look at gun crime in Australia prior to that implementation of that stricter gun control, gun crime was already decreasing. Now it may have decreased more, it may have just continued a trend, but it matters what year you start. So for example, the war on poverty programs and the programs of the Great Societies, associated with like Lyndon Johnson and things that were going on in the 1960s and forward, it was seen that poverty, especially in poor Black households, was decreasing. Okay, so people said there's relative success of the Great Society programs. However, if you look at the 1950s and times before that, Black household poverty was already decreasing. So it matters with what year you start. It helps to know what happened before and after in order to know and have context for these things. Here's a weird one. U.S. Bureau of Labor Statistics, where it's this stepped pyramid, but the biggest number is at the top, which kind of makes sense because it's at the top, but it's the smallest level, 30% on housing, and then 2% is at the bottom, but it's the biggest level and looks huge. Here's one with pitching speed, that it's just a difference of 2 miles an hour, but it looks like it's been cut in half, right? Should Scotland be independent? 52% no, 58% yes, for a total of 110%. Now, this is actually fairly common because there's usually 2 different polls go out and they get 2 different kind of answers, and that's what you see presented here. Here's one from Fox News: poverty in America. Look at the years they chose. So why these particular years? And, you know, kind of the order they put them in is a little bit confusing as well. So 1967, okay, why did it start there? Why not 1960? Why not 1970? Why not every 10 years? Why not every 5 years? Why not a graph rather than this type of presentation? So you could think about it, and to be fair to people and empathetic, how could they have, you know, presented it better? It's another CNN one. Democrats 62, Republicans and Independents 54. This Gallup poll. Well, okay, it looks like 62 is huge, 54 is small, but that's not that dramatic of a difference. So if you go back to 0, that's a different thing. Look at this one. Warmest year on record, 2012. Notice the years, 1921, 1999, 1934, 2006, 1998. They put them, why did they put them in this order? There's no discernible reason from the years, but it looks like because it seems to be this consistent raising of the temperature. And then this one changes color, and it's 55.3. But that's only 1 point more than this. So why does it look like double the size of these other ones, right? And it's a different color. It's red. It's bad. So, but a lot of people would just look and at first glance just see this, but look at the years. And then the last one here, cost of gas, national average. Last year, last week, current. So there's errors like this, or presentations like this are fairly common. They come up quite a bit. So what I want you guys to be trained to do is to look at these things and just ask good critical thinking questions of them in order to carefully evaluate what it is you're seeing and make sense of what it is. And just even if you're not sure about something, just to say, okay, what is their methodology? How did they get to that answer?